Morels are among my favorite mushrooms to find, but that is not an easy task. For one, they are visually very difficult to spot, blending in with the forest floor like camouflage. Once we combine that with the fact that their season is so short, it becomes imperative that we at least know where to look. As a beginner, this can seem like a daunting task, so I would like to offer you the following starting point. Learn the trees that morels are associated with. In the first video, we took a look at slippery elm, Ulmus rubra. Now, we are going to study ash trees of the Fraxinus genus. Let's get started. I am in North Alabama, and the one that I'm looking at in particular is green ash. That would be Fraxinus pennsylvanica. However, if that specific species doesn't occur in your area, this video will still be helpful to you for two reasons. Number one, the principles of tree ID that we're going to be using are helpful in any instance. And two, it's not this specific species, but rather the genus that I found to be associated with morels in my research. We're going to be taking a look at 4 different identification points: the branching pattern, the buds, the bark, and the leaves. But be sure to stick around until the end, where I'm going to share one more bonus tip that will help you to not get confused when you're finding it in the wild. Without any further ado, let's get started. You guys know what we're looking at. Let's start with the branching pattern. Ash trees have an opposite branching pattern. That means that the branches come off at the same point along the stem instead of alternating up it. This is actually a huge advantage when it comes to identifying the tree because there aren't that many oppositely branching trees. Whenever you found one, I like to say that you've got it made, which is an acronym for the oppositely branched trees commonly found in this area. That would be maple, ash, dogwood, and elder. The opposite pattern can be observed everywhere from the branches to the buds and the leaves. But maybe you don't have easy access to them. Maybe it's a very large and old tree. Well, that's fine. I would encourage you to just look up, because even then you can clearly see the branching pattern of the tree, and this is a really awesome first step towards identifying it. Moving along to the buds, for some reason, whenever I see ash tree buds, the first thing that pops to my mind is that they look kind of like deer hooves. Let me know if I'm the only one who thinks that. This bud comprises of a brown, prominent, but stubby terminal bud, followed by 2 smaller lateral buds, of course, on opposite sides. Now, as we move later into morel season, we're going to see these buds start to open up to tiny leaves popping out, to then going to being fully leafed out. We're going to take a closer look at the leaves in just a second, as there's a very important distinction to observe, but first, let's look at the bark. Ash tree bark is one of my favorites to observe in nature. The bark is very tight to the tree, that is, it's very hard to break off. It forms a prominent weave pattern with deep furrows that form these diamond shapes in between them. There are 2 other tree barks that we might confuse for ash. One of those is tulip poplar. Looking at them side by side, I think one of the important distinctions is that ash trees have deep, dark, and narrow furrows, whereas on tulip poplar, they are more shallow and lighter. Next, the bark pattern of ash is distinctively blockier than that of tulip poplar. Keeping that blocky pattern in mind, another tree that we could confuse would be persimmon, which also has a very prominent blocky bark. In this case, the easy differentiator is color. Ash trees have a much lighter bark, light green to light gray, whereas the persimmon bark is definitely a distinct dark brown. Finally, when it comes to the leaves, the most important characteristic is whether or not they are compound or simple. Ash trees have compound leaves, so what we're looking at here isn't many individual leaves, but rather many leaflets of a single leaf. I have linked some resources in the description for how to technically tell the difference between a simple and a compound leaf. But why is it so important that ash trees have compound leaves? Well, we've already significantly narrowed down the list of trees that we need to compare by ash being an oppositely branched tree. Now bring in the fact that it has compound leaves, and our list has shrunk even more. We're really just looking at comparing it to elderberry, which has compound leaves. Of course, elderberry just grows like a bush. So if you find a large tree with compound leaves, you can almost be certain that it's ash. Almost. For a bonus tip, I would like to show you a tree that definitely had me fooled when I started to try to identify ash species in the wild. It has an opposite branching pattern, it has a tight weave in the bark, and it has compound leaves. However, this is not an ash tree. In fact, it is a maple tree, Acer negundo. Okay, so how do we distinguish it? Well, there's a couple different things we can look at. Number one, the young branches and twigs of Acer negundo are distinctively green, something that we definitely don't find in ash trees. Second, if we take a look at the number of leaflets in a single leaf, Acer negundo is going to have 3 to maybe 5, whereas with ash trees, we're looking more like 7 or more. So with those two, you should be able to easily distinguish them if you find them in the wild.